Hello! In this simulation, we're going to investigate the vertical displacement of the coil. Here, you can see a coil with a large area and a few turns of wire above two block magnets fixed to a mild steel yoke. Watching the flux indicator, let's drag the coil slowly down through the gap between the magnets and out below them. What happens to the indicator reading? Okay, let's repeat it. It increases to about 8 squares and then it goes back to 0. Why does the flux change? Because the coil collects more lines of force or flux as it moves into the gap and then fewer as it moves out. Now let's select field lines to show the lines of force of the magnetic field between the magnets. And let's drag the coil slowly upwards through the magnetic field and observe how the flux changes as the number of lines passing through the coil changes. So this change in flux should generate an induced electromotive force in the coil. Let's click the induced electromotive force indicator and repeat the coil movement to see if a voltage is generated as the coil moves into and then out of the magnetic field. How is the induced electromotive force related to the coil movement? Yes, the electromotive force is in one direction as the flux collected increases, and in the other direction when it decreases. What do you think will happen if the coil is moved faster? Yes, a larger electromotive force will be generated since the electromotive force is related to the change in the flux. Let's test your prediction by moving it faster and faster up and down inside the magnetic field and out of it. So, our prediction was correct. According to Faraday's law, the induced electromotive force is proportional to the rate of change of the flux linkage through the coil. A coil moved like this into and out of a magnetic field can be used to measure the flux density of the magnetic field. That's all. Thanks for watching.